In 1992, the Sonic Frontier's SFS-80 stereo tube power amplifier, this guy right here, was listed at $2,750 or about $6,170 in October 2024 money. It had a rating of 6 Hz to 80 kilohertz of plus or minus half a dB. Its power output was listed at 80 watts into an 8 ohm load at 1 channel driven with a bias setting of 50 milliamps. It didn't give a rating as far as the THD at all, and those are really the only specifications that were given by Sonic Frontiers. As far as I can tell, with the exception of maybe the output tubes, it seems to be pretty original, and we'll do a tour of the outside and the back, and I'll flip it on its side, which isn't easy. This guy weighs 70 pounds. And we'll look at the circuitry that it has, and then of course there will be some test data, and I will tell you what I thought it sounded like and how it was to use. So that's the scope of this video, and right now I will get into the tour. Before we get further into this video, I wanted to interject this particular video, which was shot very recently, and the reason for this is several videos ago I mentioned something about having a hearing test done. Possibly some of you thought I was joking, but indeed I was serious about it. Being an audiophile, I thought it would be nice to know what the limitations of my hearing were, and while I don't really make strong recommendations on things, it's really about the speakers and what speakers you like. But overall, if I say something has got a little bit less bass or something, at least I wanted to have something that says that this is what this guy hears. And I'm not suggesting that other YouTubers post their hearing test results up, but I thought I would do it with mine. And I'm in my mid-60s, although I feel much younger, and I thought my hearing was fine for the most part, but I thought I would share with you what those results were. Now, before I get into the actual results, they did something that I never had in a hearing test, which was, in one case, they put like a pink or white noise in one ear, and then they have a man say a word which they want you to repeat what they say, and they do that for about 10 words. They switch ears, put the hiss in the other ear, and that kind of thing. And that was different. So the other one that they did, which I thought was more interesting, was that they had background noise. It was like being at a party with people talking, and then they actually had a woman say a sentence, probably 5 to 8 words, which you had to repeat back, which is a hard enough thing to remember the words, and they would increase the level of talking of the people in the background, so it got louder and louder, and you had to repeat the sentence. And of course, they're different sentences or words. Anyway, that was an interesting test, and then they do a bone conduction test and blow some stuff in your ear to make sure things are working and all that. So I was very happy that my results were very good on those tests. So anyway, as you can see, that's kind of my frequency response range, and they did an extended range out to 20 kilohertz. And let me just read what they said. Pure tone thresholds reveals normal hearing from 125 to 2000 hertz with a mild sensorineural hearing loss at 3000 to 4000 hertz and 8000 hertz. And normal hearing from 125 to 2000 hertz sloping to a moderate notch sensorineural hearing loss from 3000 to 4000 hertz in the left ear. High frequency thresholds were obtained out to 20 kilohertz in both ears. Speech recognition ability is excellent, 96% in the right ear, and excellent in the left ear at 100%. Quick signal to noise ratio was 1.5 dB SNR, may hear better than normal in noise. So that's kind of it. There was no recommendations for hearing aids. So I was very pleased with the results that I had. As a young man, like 1920, I worked in a nightclub as a disco DJ and played music very loud, and so that probably explains some of that hearing loss. You can take the hearing test results for what it's worth, but I thought you know, in full disclosure, I should at least tell you what my limitations are in that. So I could boost up the 3 to 4 kilohertz range. In my system, I don't really have that band on the one preamplifier that I have, but I can boost up close to that, and I can adjust the balance a little bit more to favor the left channel a bit. So anyway, that's kind of just full disclosure as to what this particular YouTube channel's hearing guy is. So for what it's worth, here's a close-up view of the front of the SFS-80. Our power on-off switch is here. We have our bias current setting meter here, and there is a red mark which is at 50, which supposedly is the optimum bias setting. This cage is removable if you so desire. This obviously is the rear of the SFS-80. We have our standard 3-way binding posts here. They're made out of copper. They're not gold plated. And the inputs are not gold plated. We do have a nice AC receptacle for your power cord that makes it easy to move around. We do have a user replaceable fuse here, and we have an operate and mute switch. Obviously, when you want to run it, you would have it in operate. When you have it in mute, I believe it just keeps bias applied to the filaments of the tubes, but it doesn't apply high voltage to the tubes. Here is what it looks like from the top. You have your 4 power supply capacitors here. Your 4 output tubes are here, and those I believe are KT99s, and then you have your small signal tubes here, which I believe are 6 DJ8s. Now, in order to set the biases of each of the tubes, you would move this knob here to whatever tube you want. Let's say it's V3, which is this guy here. You move it to V3, and then you would get a small screwdriver and adjust this potentiometer until it was reading it at the red or whatever bias current you wanted to set it at. And so it kind of makes it fairly easy to set your biases for each of the output tubes. Once you remove the bottom cover, you can see the circuit board, and it looks like it would be fairly easy to work on, and it kind of just gives you an idea of how this guy was put together, and it looks like a lot of good quality capacitors were used. Here's our standard THD SNR plot at 1 kilohertz with the SFS-80 putting out about 5 watts into 8 ohm loads. I let it set for a half an hour, just powered on, no signal going in, and then I adjusted the bias currents for 40 milliamps. We'll see how that looks, and then we'll go to 50 milliamps and see how that looks. But at 40 milliamps, you can see that the right channel has a little less gain than the left channel. Also, the distortion on the left channel is lower than the right channel, although at worst case we're 0.2%. There is not a specification from Sonic Frontiers on what the THD should be. You can see there's almost a 20 dB difference in SNRs. The right channel is better than the left channel, and that's predominantly due to these power supply hums at, it looks like 30 hertz and 60 hertz and 90 hertz and 120 hertz. So those are definitely higher than the right channel. Let me just get rid of the left channel, and there's our right channel. You can see how low those are, and when you bring up the left channel, they're higher, and that's why this SNR is the way it is. And that's kind of what's going on with it with a 40 milliamp biasing. Right now we're looking at the frequency response from 20 hertz to 20 kilohertz with the SFS-80 putting out about 5 watts into 8 ohm loads, and the bias currents have been set for 40 milliamps. The specification is that over that range it should have a frequency response of plus or minus half a dB, and we are meeting that requirement. You can see they've got some noise going on, and we've also got a suck out on the right channel here, I guess I would call it. Now if you look at the 1 kilohertz value, which is where I have this cursor at, to the suck out, we're only 0.4 of a dB or 0.44 dB difference. So it's meeting the plus or minus half a dB requirement, and you know, it has this noise here. It's a low frequency. I'm not sure that that's anything that you would really notice, and at the high end of the band we're down maybe 0.2 of a dB. So overall I would say that the frequency response is not bad. And here is the frequency response from 20 hertz to 20 kilohertz with the SFS-80 putting out about 5 watts into 8 ohm loads. The bias in this case is 50 milliamps, and it really didn't change the frequency response at all. It's still meeting the requirement. It just has that noise, that low frequency noise thing going on there, and this particular little suck out here for the right channel. Right now I've got the SFS-80 dumping out between 58 and 60 watts into 8 ohms. It has the bias set for 40 milliamps. Now there is no specification for the THD. The specification for output power is that it should be able to do 80 watts with one channel driven. Now we'll look at that in just a moment, but first we'll kind of just see where we're at. And we're pretty much at the most I'm going to get out of this thing before the distortion creeps up and gets bad. We're at about 0.6% THD for the right, 0.2% for the left, and the SNR for the right channel looks better than the left channel does. You can also see our THD plus noise is what, minus 44 for the right, minus 54 for the left. So it's kind of noisy. Now I'm going to go ahead and put it on run, and we'll see just how much more we can get before our THD hits 1%. So it's looking pretty ugly here, and we're at 63 watts, 61 watts. So I'm going to say maybe you're going to get about 58, 59 watts out of this thing. And what I'm going to do is adjust the bias for 50 mils and come back and look at this. And oh, by the way, if you're wondering what the harmonics look like, so right now we're looking at the harmonics with it putting out about 60 watts into 8 ohms. Really not a lot of difference between the odd and the even harmonics. Now the right channel's even harmonic here is higher than the third harmonic, but for the most part they're very similar with this particular amplifier the way it's running now. Right now I've adjusted the bias from 40 milliamps to 50 milliamps. When I compare it to the 40 milliamp bias at the same output power levels of 60.2 and 58.2, something like that, it is about the same. The left channel THD is a little bit higher with the 50 milliamp bias. The right channel is just a little bit lower. So really not a lot of difference in the SNRs or the gains at all. So for the most part, by adjusting the bias, you're not going to change a lot. It looks like the left channel gain went up a little bit and the right channel gain went up a little bit, a couple tenths of a dB with the higher bias. Supposedly if you run it at the 40 milliamp bias you would have a longer tube life. And in case you're wondering if there's any difference in the harmonics, let me go ahead and ramp up the power level a bit. So I've ramped up the power level a bit. So we're at almost 63 watts and 61 watts. It looks to me like the distortion has gone up for the left channel a lot, and it doesn't have as good a performance, I would say, with the higher bias setting. And looking at the harmonics, the right channel isn't as bad with the higher bias setting that it was. It's still higher than the odd harmonic here, but the even harmonic, this guy right here for the left channel, is lower than the odd harmonic for the left channel. So it's kind of a mixed batch as far as that goes for the harmonic content. Other than that, they're looking pretty much all close in level. In case you were wondering what the SF-80's output impedance was, in this case it has a 40 milliamp bias to each of the output tubes. There is no specification for the damping factor. However, if we use the value at 1 kilohertz to calculate the damping factor, it is going to be between about 4 to 4.7. So it's one of the lower damping factors that I have measured to date. This plot shows the SFS-80's crosstalk from 20 hertz to 20 kilohertz with 5 watts into 8 ohms being applied to the active channel, and the bias has been set for 40 milliamps. There is no specification for the crosstalk. It's basically better than about 67 dB, and these little suckouts here are just effects of the power supply hum. In case you were wondering what the SFS-80's multitone response is, well, here it is. The right channel does not look as good, and it's basically showing about 10 bits of distortion-free range. The left channel is a bit better, maybe 11 or 12 bits of distortion-free range. Here's the SFS-80's IMD response with 19 and 20 kilohertz tones applied, and it's putting out about 5 watts into 8 ohm loads. There is no specification for IMD, it's just kind of here for reference, and I put it into my calculator, and it shows the IMD is way low, less than, 0.03%, something like that, depending on the channel. So the IMD looks pretty good, although, like I said, there is no specification for it. Right now, we're looking at the THD SNR plot at 1 kilohertz with only the signal going into the left channel. The right channel is being muted. Now, the bias has been set for 40 milliamps for this test, and this was just to see if it could hit the maximum output power given in the specification as 80 watts. Now, we're at about 1%, and we're at 65 watts, so I'm going to say that there's not a lot of difference with having single channel driven or both channels driven, at least for this case. It's still a little bit away from the maximum output power of 80 watts into 8 ohms without any specification on the THD, but usually 1% is given as kind of the maximum amount of THD for the output power. So that is kind of what it looks like. Right now, there is a 1 kilohertz square wave going into the SFS-80, and we're looking at the output. It's putting out about 9 volts into an 8 ohm load. I believe I was using the left channel. They both were pretty much the same. The rise time is measured at about 4 microseconds. There is no specification for it. It's just kind of for comparison. And if we move the frequency up to 10.25 kilohertz, the rise time stays about the same at about 4 microseconds. At 100 hertz, the rise time is also about 4 microseconds. Here we have a difference in phase between the input and the output, and at 1 kilohertz, there basically is no phase difference. If we go to 100 hertz, there really is no phase difference between the input and the output. And at 10 kilohertz, we do see a bit of phase difference between the input and output. I'm guessing that's probably around 10 degrees. If we look at the difference in phase between the left and right channels with the same signal going into both of them, so with a 1 kilohertz sine wave going in to both left and right channels, the phase difference is basically 0. And at 10 kilohertz, there is just a very small difference in phase between the left and right channels. I do have a correction to make regarding the frequency response. It's actually plus or minus half a dB over the range from 6 hertz to 50 kilohertz. Now, I only tested it from 20 hertz to 20 kilohertz, and it met that half a dB requirement, although you did see that noise, particularly in the right channel. It had I'll call it a suck out there, under 100 hertz. I said it was within the plus or minus half a dB. I'm not sure that's anything that one would hear, and I certainly didn't hear it when I listened to it. More on my listening in just a little bit. As far as how it measured, it didn't hit its 80 watts with one channel driven. It got up to the mid 60 watt with one channel driven into 8 ohm loads. I didn't bother testing with 4 ohm loads, just with the 8 ohm loads. And it did have a good frequency response other than the noise at the low part of the band, particularly the right channel. But, it did pretty good as far as, its THD for a tube amplifier. It was fairly decent. Probably you could get maybe 60 watts into 8 ohms before the distortion got much over %, but it wasn't able to hit its 80 watt per channel with one channel driven requirement, and that was either with the 40 milliamp or the 50 milliamp bias settings. I do like the idea of having a meter there to adjust your biases. It's pretty easy. I would let the unit just sit there idling for at least a half hour before I would adjust the bias from a cold start. And I did notice after I'd been listening for a half hour or so at louder levels that the bias had drifted, and so I had to readjust it. So I don't have a tube amp that has bias settings. For some reason in the 60s, Macintosh figured out a way to make tube amplifiers without having any pots for bias settings. Go figure. But as far as having the meter, there's other companies that provide jacks for measuring the biases with the external voltmeter. I think other gear does have a meter that you can switch between the different tubes. I guess that's part of maybe the fun of doing that. I really hope my good buddy Richard doesn't adjust them. I'll set them for him, and hopefully he doesn't go in there and try to adjust it. But I would probably run it at 40 milliamps. It's less stressful on the tubes, and I really didn't see any difference whatsoever running it at 50 milliamps for the bias current. So that's kind of just my little take about that. As far as listening to it, I connected it to the Carver C1 preamplifier that I own, and then to the Wilson Watt 3 Puppy 2 loudspeakers, and listened to a normal variety of music. After it was on for a half hour, I double checked the biases, made sure they were set at 40 milliamps, and I just listened for hum and hiss, and there was very little. It just really quiet for the most part. I really had to strain to hear the slightest amount of hum and hiss, but it's very quiet amplifier. And then just listening to it, it's I'd say neutral. I mean, it had highs, it had lows, and it seemed to amplify without adding a lot. I didn't think it had a warm sound or cold sound, just kind of neutral sound, which is pretty much what most amps have. When that I've listened to, when I cranked it up to where my SPLs were in the 90 dB SPL range, it handled that no problem at all, and it wasn't stressed. And the tube amplifier is going to run warm. It's just the way they are, of course, but it wasn't stressed at all at the higher settings, and it just sounded like a nice tube amp. I mean, some people like that kind of stuff. I have a pair of the Macintosh MC30s or the Mac Kit 30 monoblock amps that I'll listen to every now and then. There's just something about seeing the the glow of the tubes, and does this sound any different than any other amps? I wasn't ambitious enough, to be honest, to hook it up to another amp and do an A/B test. But it sounded just fine. It'll work just fine for Richard. It has plenty of power for any speakers he's going to probably ever drive. And it's a nice clean look. I thought the build quality, as you saw on the tour, was pretty good. Now, I did see some things I thought as far as some of the solder joints and the connections, and I believe I pointed those out in the tour, where I thought that was a little sloppy, but it works. It's been working for what, 30 years or so. So it seemed to work well, and it's a nice, attractive piece of gear. I think I would keep the tube cage on it if it were mine, the way it is right now. But some people want to see the tubes out, so that's kind of a decision you would have to make if you were the owner of this. So anyway, that's my take on the SFS-80 stereo tube amplifier. If you have not subscribed to the channel, please do so. It's the only thing I ask. It helps the channel grow. And if you have comments or questions, of course, please leave them, and I try to respond to them and enjoy reading them. And if you like the video, give me a thumbs up, as that helps with YouTube's algorithm. So once again, I thank you for watching, and until next time, have a great day or night.